Hello. This is a case study employing the biometrics software together with some scenarios recorded at Troysgate in December 2019. In this presentation, we are going to talk about two exercises. One is a shooting scenario performed by a military pilot, Matty, and a second one is a no-shoot scenario performed by a police officer, Toby. Both of them were suited up with biometric devices, including recording glasses and EEG. By converting EEG results from these multiple lines into this visually appealing heat map, the data literally exploded with information. Let me demonstrate. Here, we are able to compare the brains of two participants. Toby, a left-handed police officer with a training and experience in hand-to-hand combat situations. We see his brain in the beginning of this exercise. It is somewhat excited. He is ready to jump into the situation. The second image, he is in the most heated point of the conflict, where he has to make a crucial decision whether to shoot or not to shoot. The EEG is showing that the brain is generally calmer than at the beginning. Finally, at the end of the exercise, his brain is able to considerably cool down. Two things are worth mentioning here. The police officer had a significantly higher heart rate throughout the scenario, between 121 and 133 beats per minute. 115 to 145 beats per minute are the optimal survival performance level for complex motor skills, visual reaction time, and cognitive reaction time. Also, looking at the very front of his brain, where the decision-making takes place, we can see that throughout the exercise it was activated, but especially so in the most critical moment. And now, let's look at the participant that is not used to face-to-face conflict with deadly force situations. He entered the scenario in a calmer state than the policeman, but during the exercise, his brain became overactive. The middle EEG image reveals that in the middle of shooting, his decision-making is not active, and motor planning is less active as well. After the scenario, the brain did not return to the original calm state. We also provide a file where EEG images of Matty's performance are annotated step by step. We did not do that for Toby because Toby is left-handed. There are only about 10% of left-handed people on planet Earth, and their brain is organized differently. The brain maps are mostly made for right-handed people. That is why we are looking at Matty's EEG. Throughout the exercise, we can track Matty's brain activating and deactivating various areas. For instance, the moment the perpetrator begins to move about the stage, the part responsible for executive function lights up red. Then the area that plans motor action kicks in. At some point, his entire visual and auditory processing areas are all lit up. We see areas with mirror neurons, areas that evaluate tone of words and their emotional implications. The perpetrator shoots first. The participant discharges 10 bullets. Interestingly, the brain activity continues to change while the participant is shooting. So if at the set-off, the motor planning and the decision-making are active, by shot number 5, the decision-making area is cool green, and the dark red areas are now almost exclusively in the motor center that operate right hand, fingers, and both arms. In this state, if you ask a person, why did you keep shooting? They would not be able to give you an answer. Another interesting observation is a so-called Brodmann's Area 9 on the right side. Even when the EEG image was almost all red, this area remained turned off all throughout the exercise. And yet, the moment the curtain began to close, this area lights up almost exclusively. Now, this area of the brain is responsible for recognizing emotions and suppressing sadness. And finally, This is a script of the scenario just discussed, where various areas of the brain are included as they get activated. So, for example, FT9 is the name of an electrode on the EEG cap. This electrode corresponds with Brodmann's area 20 on the left, which is BA20L. Once the Brodmann's area is identified, we can tell what function that specific place performs. The color tells you how strong the signal is. So blue means not activated and dark red means the most activated. I hope you enjoyed this presentation. Thank you.